Hello, I welcome you all. The problem reads, the assembly consists of two blocks, A and B, which have a mass of 20 kg and 30 kg respectively. Determine the distance B. Determine the distance B must descend in order for A to achieve a speed of 3 meters per second starting from rest. Alright, so we are being asked to determine the distance B that must descend in order for A to achieve a speed of 3 meters per second. This problem is coming from the Engineering Mechanics and Dynamics, a 14th edition by RC Hibbeler. Okay, so let's say this one is our reference. Okay, so we have A there, we have B there, and then let's say B descends by this distance. Use another color. It descends up to there. Let's say it descends up to there, right? Let's say it descends up to there, like so. Okay, and then this point the ascends. Okay, let's say it ascends up to there. Okay, let me extend this line just a little bit. Alright, so let's say it ascends up to somewhere there, like so. Okay, so our references, we have this direction like so. So let's say we have this one, we are going to call it as our SB, then this one we'll call it as HB. Okay, this one is SB, this one is SA, and then this one we call it HA, and this one we call it HB. Sorry, this one is HB, this one is HA. Right, so let's write down the kinematic equation that relates the position, later on the velocity. So we have 3SA plus SB equal to L. Therefore, 3 delta A plus delta B equal to 0. Okay. So the question here is to find distance B. Okay. So you know what distance B is. So we have distance B. Okay. Going down. Right. And then our A is just equal to delta B divided by 3. So this one, you just move it like so. So this delta B, we say it is just equal to HB. This one is equal to HA. Okay, which is just equal to HB divided by 3. Right? So let me write it properly. So delta A is just equal to HA, which is equal to delta B divided by 3, okay, equal to HB divided by 3, and this is going up. And then we have velocity there, which is just 3 VA plus VB equal to 0. Therefore, our VB going down, then we'll have our VA, which is just equal to VB divided by 3 going up. Then applying the conservation of energy. Let's say this point here is 1, this is 2, this is 1, this is 2. So say the kinetic energy at point 1 plus the potential energy at point 1 is equal to the kinetic energy at point 2 plus the potential energy at point 2. Kinetic energy is just equal to half mv squared, and the potential energy is just equal to Vg, which is the gravitational potential energy plus the elastic potential energy. T1, since this is coming from rest, right? So it's equal to 0. V1g, okay, is also equal to 0. And in fact, V1g is just equal to V1e, which is just equal to 0. T2 is just equal to half. We'll have some kinetic energy, V1 squared. So let me separate this. I'll say VB squared plus half, which is also B, half MA VA squared. So writing it in terms of B. So say just half MB VB squared plus half MA VB divided by 3, all of it squared, right? That's what we said A is. And then V2G, this is just going to be equal to for B. That term is this one is our datum here, and then this one is our datum here. Okay, so for B, it's going to be negative WB HB, and then for A is a positive WA HA. So writing this so that we replace HA with B, so this just becomes like so, plus WAHA, we said is just equal to HB divided by 3. Right. What else? Then V2E is just equal to 0. So writing this in one equation, I will have a 0 just equal to half MB VB squared plus half MA VB over 3 squared minus WB HB plus WA HB divided by 3. So let's assign some numbers. MB is just equal to 30. VB in fact, this I need to write it in terms of A. Sorry. So I'll write this in terms of A. So in terms of A, So my VB is just equal to VB is going down. Sorry, I didn't realize to say we are given A. So here my VA, in fact, which is going up, is equal to 3 meters per second, and therefore VB going down is just equal to 3 VA, which is just equal to 3 by 3, and is equal to 9. Okay, so here I'll need to rewrite this. So can I just write this from this point? So I have my T2 is just equal to a half M VA squared plus half, this is A, MB, then 3 VA squared, right? And then V2G, this is just equal to minus WA, sorry, this is a plus, WA, that term is down, HA, and then minus WB, HB is just a 3HA, right? And then V2E is just equal to 0. So let's put this in one equation. So we'll have a 0 is equal to half MA VA squared plus half MB 3VA squared plus WAHA minus WB 3HA. Let's put numbers there. So half our MA is just a 20, our VA is just a 3 squared plus half 30 3 by 3 times 3, which is just a 9. So this just gives us a 9 squared. Then plus WA is just a 20 by 9.81 by HA okay, then minus 30 by 9.81 by 3HA. Okay, so working out HA there, this just gives us, let me just create a boundary there like so. So here I will have my HA is just equal to, grab the calculator, 0.5 by 20 by 3 squared by 0.5 by 30 by 9 squared, and then there we go, and we'll say divided by 30 by 9.81 minus a 20 by 9.81. 30 by 9.81 by 3 minus a 20 by 9.81. Right, so H1 is just equal to 90 like so, 1.90 meters. And therefore our HB is just equal to 3HA, which is just equal to 5.70 meters. We check it again, 0.5 by 20 by 3 squared plus 0.5 by 30 by 9 squared, okay, divided by 30 by 9.81 by 3 minus 20 by 9.81. Alright, so we have found the distance B that it must descend in order for A to achieve the speed of, so found both of them. Okay, so I hope this particular video is helpful. I hope this particular video is helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.